Welcome students. In our previous video, we discussed how do we convert a ER diagram into a relational tables. Today we will see few more examples, especially focusing on our relationship sets. When I say a relationship, they are categorized into four different types: one to one, one to many to or many to many. So when I see this one to one, a single instant of one entity is associated with only one instant of another entity, participating entity. Or when I say one to many, one instant of an entity can be associated with more than one instances of another entity. This is one to many. Many to one. There are two parties, it's a binary relationship with two participating entities. Many instances of one entity set, or let me put it the other way, many instances of one entity set can be associated with one instant of other entity set. Similarly, we have many to many, where many instances of one entity set can be associated with many instances of the other entity set. We will try to see the example and we will one by one take up and see how we can convert it into a table. Coming to one relationship. We are talking about a binary relationship which is associated with one-to-one format between student and a course, which means that each student can take up only one course. Each student can enroll into only one course. Now, how do I convert this into a table? Remember, whenever we have entities, we have converted them into table, as the table name is going to be the entity name and the attributes are going to be the columns of the table, with the key attribute becoming the primary key there. So, here the relationship is just associated by using the primary key of another table as a foreign key in the other table. So, in this particular case, I can have two entity tables defined, student and course, with course code as a primary foreign key, course code which is a primary key of course as a foreign key in student, or the other way round. The roll number which is a primary key of student can be given as a foreign key in course. Look at this, student and course are the two entities which are created, in which the roll number can go as a foreign key into course. Okay, and here in the opposite side, if we see, the course code is going as a foreign key into your student relationship. This is how we can implement a one-to-one relationship, which is simple, straightforward way of doing the things. Now, coming to the next slide, here we are going to represent one-to-many relationship. Again, I am taking the same example, one-to-many between student and course, where it says one student can enroll into many courses. Now, how do I represent this particular thing? Here, a slight change, what we have to keep in mind is the key attribute of the many side entity. V is mapped as the foreign key in one side relationship. In one-to-one relationship, it can be either way. Either you take course primary key as foreign key into student, or student primary key as foreign key in course. But here I have a restriction that the primary key of the many side will go as the foreign key into the one side entity, and automatically the descriptive attribute of the relationship itself will get into the one side entity. This is how we generate. Look at this, separate relations are created for each participating entities, that is student and course, and and the key attribute of many side entity is mapped as the foreign key into one side relation. So, in our case the primary key of course will be included into student as the foreign key. Then the attributes of the relationship set itself will always go as the attributes into the one side entity. Keep this in mind. The same thing holds good for many to one also. So, let us just try to see that. Many to one. Here I am saying many students will enroll into one course. A particular course can have many students. So, we are taking many to one. So, automatically the primary key of the many side entity will go as a foreign key into the entity set in one side. Look at this. Roll number goes as the foreign key into the course table, and the other attributes of the relationship set will always get into the one side entity. So, here one side is course, that is why date of enroll will get into one side. So, this is many to one. Let us see what will happen in case of a many to many relationship. Many students will enroll into many courses. One course will have many students, many courses will have many students will take many courses. When both the sides are many, remember the relationship set itself is mapped as a separate relation. So, we are going to have one additional relation called as enroll. Now, as we discussed earlier, the primary keys of the participating entities will become the attributes in that relationship set. In the relationship set mapped into a table, the primary key of the participating entities will become the attributes, and they together make a composite primary key. They together make a composite primary key, and all other attributes of the relationship set will also get into that particular relation. Then with the remaining attributes, you will have separate. The attributes of the relationship set becomes a simple attribute for that relation, and separate relation is created for other participating entities. So, for this student and course, you will anyways have two entities created with their respective attributes. Okay? So, here remember the entity relationship set itself goes as an entity. So, on the whole, this is one example where there are multiple entities and there are different types of relations between them. Here we have employee gets a salary. So, a one-to-one relation. So, remember employee and salary are going to be the two entities which are going to be created, and in that case we do have the salary ID, which is a primary key here, enrolled or inserted into employee as a foreign key, one to one. Look at this, project and employee, a one to many relationship. In this case, as we discussed earlier, the many side is employee. The primary key employee ID will become the foreign key in project. If you see here, project, the employee ID has become the foreign key here. And here this particular relationship is included, the attribute of the relationship entity goes into the single side. So, project is the single side entity. So, that takes this particular start date. Okay. If you see here many to one again, okay, we do not have any many to many relationship. So, employee and company, again employee ID will get into company, and this particular relation attribute date of joining will get into a one side, that is company, into the company entity. Now, here is one specific example. Look at this, there is actually a ternary relationship. Okay, we have employees and dependents. Employee purchase the policies and dependents will get the benefit. Now, how do I represent this particular thing? We can go by a shortcut method by using the advantage of the key constraints here, we can combine the purchaser information with the policies. Here we say employees purchase the policies. The information of the purchaser can combined with the policies and beneficiary information with dependents, because dependents are the beneficiaries. So, what information, what policy ID? Now, together with this policy ID and P name, I will be able to identify them. Look at this particular table. There are two tables created, policies and dependents. Policy will contain the employee number as the foreign key within this, because we should know which particular employee has purchased this policy. Okay. In the same way, we have got dependents table in which the policy ID refers to this policies table, which in turn has got SSN, which will know which particular employee has purchased this policy, and through this policy who is the dependent who is getting benefited. So, the P name, the dependent's name and the policy ID will become the primary key in this dependents table. So, in this particular way, we will be in a position to combine both the informations into these two separate. Will help the deletion of an employee from the company will lead to deleting all the policies owned by that employee and their dependents in the beneficiary of the policies. Because as long as the employee is there, the policy holds good and the dependents will get benefit. If the employee is no more in that company, that policy and the dependents will no longer be associated. So, this is on delete cascade, because here if you see SSN, it is related with the employee. So, if this particular SSN, that particular employee is deleted from the database, automatically all the linked fields will make the corresponding rows to be deleted from the policies and the dependents tables in turn. Okay. This is few of the examples where we have considered different components of ER diagram and how it is mapped into the relationships or relations in the relational model. Thank you.